Boolean algebra can get a little bit complicated, especially when you have a truth table, you're extracting all the highs, and then you need to remember all the rules of Boolean algebra, and it can get a bit overwhelming. So something that we do to make our life a little bit easier is Karnaugh mapping. I will say Karnaugh mistakenly, it's Karnaugh, but because I also lecture in thermodynamics, I keep thinking about the Karnaugh engine. So bear with me, that's what I usually mean. The idea behind it is we map a truth table on a Karnaugh map and we can extract a Boolean expression to build a very simple logic gate out of it. However, to use the Karnaugh map effectively, we do need to learn the rules of the game. So that's the purpose of this video. I'm going to teach you the rules. To the whiteboard. So this would be a 16-line truth table and we've expressed all the highs in the table. We can add in the zeros if we want, but we can ignore them. It's just a lot easier. You know you're not allowed under the PC where all the spicy wires are. The first rule of Karnaugh mapping is that we don't talk about Karnaugh mapping. But the real rule is that when we draw our grid, we don't draw it in the order of the truth table. We write it in the order of 0, 0, 0, 1, 1, 1, 1, 0. That's because each neighboring cell, i.e. the cell on the right, the left, up or down, can only differ by 1 bit. So this guy is 0, 0, 0, 0, but this guy is 0, 1, 0, 0. Only 1 bit changed. And what's important is the bit on the most right-hand side continues and changes only by 1 bit on the left-hand side, and the bit on the most top-hand side connects to the most on the bottom, i.e. this cell is 0010 and this cell is 1010. Only 1 digit changed, so they are neighboring cells.